The weighted average calculate the average while taking into account the number of samples in each classes. Hi everyone, in this project we are going to build a machine learning system to predict the next day direction of the Nifty 50 market. The goal is simple. We want to predict whether the market will go up or down tomorrow. We define 1, which means market goes up, 0, which means market goes down. Since we are predicting two categories, this becomes a binary classification problem. In this stage, we will build our first model, logistic regression, which will serve as our baseline model. Let's start step by step. So first, we are going to import all the necessary libraries for this project. So here, yfinance is used to download financial market data from Yahoo Finance. Pandas is used for data manipulation and analysis. Numpy is used for numerical operations. From scikit-learn, we import several machine learning tools. Train, test, split to divide the data set into training and testing data. Logistic regression, the machine learning model we will use. Accuracy score and classification report to evaluate the performance of our model. Alright, so now we are going to download the data set with the help of yfinance. Type this data, which means variable name, equal to yfinance.download. NSEI, which means National Stock Exchange of India. The data that we are going to download, that is from 1st Jan 2015 to 31st of December 2024. Then click on run button, which means we are telling the yfinance library to download historical data of the Nifty 50 index from Yahoo Finance. To check the column names, so for that we need to type data dot column and click on run button. So here you can see the list of column names: close, high, low, open, volume. Alright, so now we are going to remove all the missing values. So for that we need to type data equal to data dot drop now and click on run button. Alright student, remember earlier we downloaded the Nifty 50 dataset using yfinance. We store that dataset in a variable called data. So the data represent our dataset, which is like a table similar to Excel. The next step is to create our first feature for machine learning model. In financial analysis, one of the most important measure is return, which tell us how much the price has changed from one day to the next. So now we will create a new column called return in our dataset. So let's look at the codes. So now let's understand this line step by step. So first part, return column from the data frame. The square brackets are used to access or create a column. The text returned inside quotes is the name of the new column. So this part means we are creating a new column called return inside our dataset. So here you can see equal, which means assignment operator. So students, here we are selecting the close column from our dataset. The close price represents the price at which the market closed on the trading day. So .pct underscore change calculate the percentage change between value. Then click on run button. Now we are going to check or verify whether we have created new column name called return. So for that, type here data dot head data dot head and click on run button. So here you can see this is the column name that we have created earlier. So now we'll understand the head function display the first 5 rows of the data set. This helps us confirm that the return column has been successfully added to our data frame. The next step is to create moving average indicators. So moving averages are widely used in financial analysis and trading strategies because they help us understand the trend of the market over a specific period of time. So now we will create two moving average. So now first a 20-day moving average which represent the short-term trend, and second that is a 50-day moving average which represents the medium term trend. Alright, so student, let's look at the code. So here you can see we create a column called MA, that is moving average 20, in the data frame and assign it a 20-day rolling mean of the close price, or which we are creating a new column called MA moving average 20 in our data set. Data close. This select the close price column from the data set. Ruling 20. The ruling 20 function create a moving window of 20 days. This means the model will look at the last 20 days of closing price. The mean function calculates the average value of those 20 days. So this gives us the average closing price over the last 20 days. This line is very similar, but instead of 20 days, we calculate the 50-day moving average, which represent the longer term market trend. In this step, we create two new features, that is moving average 20 and moving average 50. Moving average help the machine learning model understand both short-term and longer-term market trends. And then click on run button. So next step, we will create target variable. Alright, now that we have created our technical indicators, the next step is to define the target variable for our machine learning model. Now the target variable tells the model what we want to predict. In this project, we want to predict, that is want, which means market will go up tomorrow. 0, which means market will go down tomorrow. In this step, we create a new column called target, which represents the direction of the market on the next trading day. If the next day closing price is higher than today, closing price. If the next day's closing price is lower, we label it 0, meaning the market went down. So here you can see data target. This create a new column called target. The shift -1 function move the close price one row upward, which give us the next day's price. Data close, which indicate that tomorrow price versus today price. np.where function checks a condition. If the condition is true, it return 1. If the condition is false, it return 0. Then click on run button. Alright, so now after creating the target variable, the dataset may contain some missing values. This happened because operations such as percentage change, moving average, and shifting data require previous or next rows to perform calculation. To ensure our dataset is clean and suitable for machine learning, we remove any rows containing missing values using the drop-now function. So for the type here, data equal to data dot drop now. Then click on run button. So next, let's check the data set by typing data dot head, data dot head, and click on run button. So here you can see all the column names of the data set. Now that we have created all the required features and the target variable, the next step is to separate the data set into input features and the target variable. The input features will help the machine learning model learn pattern, and the target variable represent what we want to model to predict. Now let's look at our code. So here we create a variable called x, which contain the input feature for our machine learning model. Features we use are return daily price movement, return MA, which stand for moving average 20 short-term trend indicator, MA moving average 50 medium-term trend indicator. This feature help the model understand the behavior of the market. And then y equal to data target. Here we define y, which represent the target variable that the model will try to predict. The target column tell us 1, which means market goes up tomorrow. 0 means the market goes down tomorrow. Now that we have defined the input features x and the target variable is y. Now the next step is to split the dataset into training data and testing data. This allows us to train the model on one part of the data and evaluate it on another part. Then click on run button. Now that we have defined the input features x and the target variable y, the next step is to split the dataset into training data and testing data. This allows us to train the model on one part of the data and evaluate it on another part. Now that we have defined our input features x and the target variable y, the next step is to split the data set into training data and testing data. The model will learn from the training data, and then we will evaluate its performance on the testing data. So here you can see x underscore train equals x colon int integer len of x multiply by 0.8. Here we create a variable called xtrain, which contained the first 80% of the feature dataset. So here xtrain represent the training features which will be used to train the machine learning model. Click on run button. Now that we have defined our input features x and the target variable y, the next step is to divide the dataset into training data and testing data. The model will learn pattern from the training data, and we will evaluate its performance using testing data. In this project, we will use 80% of the data for training and 20% for testing. To perform this split easily, we will use the train underscore test underscore split function from the scikit-learn library, which we imported earlier. In this project, we will use 80% of the data for training and 20% for testing. Now let's look at the code. The train underscore test underscore split function divide our data set into training and testing set. Here x and y. Here we pass our features x and target variable is y to the function. So test underscore size equal to 0.2. This means 20% of the data set will be used for testing, while the remaining 80% will be used for training. So here shuffle equal to false. Since this is a financial time series data, we set shuffle equal to false. So the chronological order of the data remains intact. This ensures the model learned from past data and predicts future data. Then click on run button. Alright, now let's quickly check the size of our training and testing data set. By typing this, print x underscore train dot save, print underscore test dot save. The save function tells us the dimension of our data set. It shows the number of rows and the number of columns. Then click on run button. So here you can see x underscore train dot save has a 1927 rows and 3 columns, and x underscore test has a 482 rows and 3 columns. And the next step, we will create an instance of the logistic regression model. Now that we have prepared our training and testing data set, the next step is to create our machine learning model. In this project, we will use logistic regression which is a commonly used algorithm for binary classification problem. Now look at the code. Here model is simply a variable name. We are creating a variable that will store our machine learning model, so later we can use it to train the model, make prediction, evaluate performance. Think of it like a container that will hold our train algorithm. The equal sign means assignment. So we are telling Python, take the logistic regression model and store it inside the variable called model. So here, logistic regression function is a machine learning algorithm provided by the scikit-learn library. It is used for classification problem where the goal is to predict categories. In our project, the categories are: 1 means market goes up tomorrow, 0 which means market goes down tomorrow. So logistic regression will learn pattern in the data and try to classify whether the market will go up or down. So here the parenthesis means we are creating an instance of the logistic regression model. In simple terms, we are initializing the algorithm so it is ready to be trained. At this point, the model exists, but it has not learned anything yet. Learning happens in the next step using fit. Then click on run button. But the model still doesn't know anything about the data. Training happened in the next step. So we are creating a logistic regression machine learning model and storing it in the variable called model so that we can train it using our dataset. So after creating the model, the next step is training the model. Now that we have created our logistic regression model, the next step is to train the model using our training dataset. Training the model means allowing the algorithm to learn pattern from the historical data. Now look at the code. So here you can see model.feed x underscore train comma y underscore train. The line of code trains the machine learning model. So here model refers to the logistic regression model we create earlier. This variable now represents the machine learning algorithm that we will train. The fit function is used to train the model. It allows the model to learn the relationship between the input features and the target variable. X underscore train contains the training features. There are created earlier. The model analyzes these features to find patterns in the market behaviors. Y underscore train contains the target value. This value represents the market direction. The model compares the features with these labels to learn how the market behaves. During this training process, the logistic regression algorithm analyzes the relationship between the input features and the target variable, and it adjusts parameters to best classify whether the market will move up or down. In simple terms, this line trains the model by allowing it to learn patterns from the training data. Once the model has been trained, the next step is to use the trained model to make a prediction on the testing dataset. Now that our model has been trained, using the training dataset, the next step is to use the model to make prediction on the testing dataset. This will allow us to see how well the model performs on data that it has never seen before. To do this, we use the predict function. Now click on Run button. Now that our model has been trained using the training dataset, the next step is to use the model to make prediction on the testing dataset. This will allow us to see how well the model performs on data that it has never seen before. To do this, we use the predict function. Now look at the code. Here, prediction is a variable that will store the result generated by the model. This result presents the predicted market direction for the testing dataset. Model refer to the logistic regression model that we trained earlier. The predict function is used to generate predictions from the trained model. It takes the input features and predicts the corresponding target values. X_test contain the testing features that the model has not seen during training. The model will analyze these features and predict whether the market will go up or down. Now let's execute this line to predict. Then click on Run button. Alright, let's take a look at the first few predictions generated by model. So here, this will display the first 10 predictions made by the model. Then click on Run button. So here, we are looking at the first 10 predictions generated by our model. Each number represents the predicted market direction for the next trading day. In our project, the target variable was defined as follows. 1 means the market goes up and 0 means the market goes down. Since all the values here are 1, the model is predicting that the market will go up for these observations. This does not necessarily mean the model is perfect. It simply means that based on the pattern, it predicts an upward movement for these samples. However, prediction alone are not enough. We now need to evaluate how accurate our model is. To do this, we will use some evaluation metrics. To measure the performance of the model, we will use accuracy score and classification report. First, let's calculate the accuracy of the model. So now let's look at the code. Now that we have generated prediction from our trained model, the next step is to evaluate how accurate the model is. One of the simplest way to evaluate a classification model is by calculating the accuracy score. Accuracy measures the percentage of the correct prediction made by the model. To calculate the accuracy of our model, we use the accuracy score function. So now let's look at the code. Here you can see print function. The print function is used to display output on the screen. It helps us show the result of our calculation in a readable format. Here, accuracy. This is simply a text label that will appear before the accuracy value. It helps us clearly identify that the number shown in the accuracy of the model. The accuracy score function calculates the accuracy of our predictions. It compares the actual values with the predicted values and computers the proportion of correct prediction. Y underscore test contain the actual target values from the testing dataset. These are the true market direction that we want to compare against. Prediction contains the values predicted by our machine learning model. These are the model's estimates of whether the market will go up or down. Let's execute this line of the code to calculate the accuracy of the model. And click on run button. And then this is the output of the accuracy. So out of every 100 prediction, the model correctly predicts the market direction approximately 58 times. Financial markets are extremely noisy and difficult to predict. Even professional quantitative trading models often achieve around 55 to 60% accuracy when predicting short-term market direction. Therefore, an accuracy of around 57% is actually a realistic and reasonable result for a baseline model. Remember that logistic regression is our baseline model, which means it provides a reference point. Later, we will compare more advanced models to see if they can improve this performance. While accuracy gives us a general idea of model performance, it does not tell us the full story. To better understand how the model performs for each class, we will now look at the classification report. So the model achieves an accuracy of approximately 57.7%. Almost we can say 58%. Mainly it correctly predicts the market direction in about 58 out of 100 cases. Considering the randomness and volatility of financial markets, this is a reasonable performance for baseline machine learning model. While accuracy gives us a general idea of the model's performance, it doesn't provide details information about how the model performs for each class. Now, what we have generated prediction from our trained model, we want to evaluate how well the model performed. Earlier, we calculate the accuracy while tell us the overall percentage of the correct prediction. However, accuracy alone does not tell us how well the model performed for each class. To get a more details evaluation, we use a function called classification report. Now let us look at the code. This line of the code generates a detailed performance report for our classification model. To evaluate a machine learning model, we need two things. First, the actual values. Second, the prediction values. The classification report compares these two sets of values to measure how well the model performed. The print function is used to display the result of the screen. It allows us to view the classification report in the output. The classification underscore report function is provided by the scikit-learn library. It calculates several evaluation metrics for classification model. These metrics include precision, recall, F1 score, and support. Y underscore test represent the actual values from our testing dataset. The values show the true market direction, whether the market actually went up or down. Prediction represent the values predicted by our trained machine learning model. This prediction is indicate whether the model believes the market will go up or down. The classification report compares the actual values y underscore test with the predicted values prediction to evaluate the model's performance. Based on this comparison, it calculates metrics such as precision, recall, and F1 score. Now that we understand what this code does, let's execute it to generate the classification report. Then click on Run button. So here you can see precision measures how many of the predicted positive cases were actually correct. For example, when the model predicts that the model will go up, precision tells us how often that prediction is correct. Recall measures how many of the actual cases were correctly identified by the model. It tells us how well the model detects all the true market movements. F1 score is a balance matrix that combines precision and recall. It provides a single score that reflects both false positive and false negative. Support represents the numbers of actual samples belonging to each classes. Of actual samples belonging to each classes. 209 observation where the market went down. 273 observe where the market went up. For class 1, which represent upward market movement, the recall is 0.93. This means the model correctly identifies most upward movements. However, class 0 represent downward movements. The recall is only 0.12, meaning the model struggles to detect market decline. This suggests that the model trained to predict upward movement more often than downward movements. The overall accuracy of the model is 0.58, meaning the model correctly predicts the market direction above 58%. The overall accuracy of the model is 0.58%, meaning the model correctly predicts the market direction about 58% of the time. So the micro average calculate the average performance across both classes equally. The weighted average calculate the average while taking into account the number of samples in each classes. From this report, we can observe that the model performs significantly better in predicting upward market movements than downward movements. This behavior is quite common in financial data set because market trend to show a slight upward bias over time. Overall, the logistic regression model achieves an accuracy of about 58%, which is a reasonable result for a baseline model in financial market prediction.